Look at lessons 2.1 through 2.4 plus I and 7. I and 7, if you remember, was a lesson we did about similar figures, so just in case we don't end up coming back to that. So page 127, just looking at a little vocabulary here. Number 1, for two quantities x and y, if y is always a constant multiple of x, they have a or an, we would say, proportional relationship. Number 2, the value of the ratio y over x of two proportional quantities x and y is called the, and that would be the constant of proportionality. That's that k value we've been talking about. We talked about in lesson 4. K is equal to y divided by x. And number 3, an equation that shows two ratios are equal, and that would be called a proportion. Okay, so for example, if we have x over 4 equals 3 over 8 or something like that, that's a proportion equation stating that they're equal. So if we look at our first part of the topic 2, they kind of combined these into one. We've got ratios, rates, unit rates, and we can have things with fractions too. So if you look at number 1, mealworms are a healthy food for wild songbirds. Probably if you were in the wild, lost somewhere, they could be a healthy food for you too. But Adam buys 3.5 ounce container of mealworms for $8.75. Marco buys a 3.75 ounce container for $9.75. Which container is the better deal? So finding which one's the better deal, we've talked about a lot in this lesson, is finding unit rates. Unit rates, anytime if there's money involved, we're going to want to take the money divided by the other thing generally. So $8.75 divided by 3.5 ounces, that would tell us how much it costs per 1 ounce or how much it costs per ounce. So when you divide that out, you get 2.5, and since we're talking about money, we can go ahead and put a 0 on the end of that, so that would be $2.50 per ounce. So for our second option here, if we do $9.75 divided by 3.75 is 2.6. Again, if we put a 0 in behind that, that means $2.60 per ounce. So $2.50 an ounce or $2.60 an ounce. The better deal would be our first container. So we would want to make a statement about that. The first container is the better deal, or Adam's container is the better deal because it costs less per ounce. Number 2, we've got a similar situation here. Painter mixes 2.5 pints of yellow paint with 4 pints of red paint. So we can color code this if you want to. To make a certain shade of orange paint. How many pints of yellow paint should be mixed with 10 pints of red paint to make this shade of orange? So we could look at this. We could, divide it out and try and get things to be equal. Probably what I would recommend is if we just do a proportion. So we're trying to find how much yellow paint for 10 pints of red paint. So the other part, if we're consistent here, we put our yellow over our red, so 2.5 over 4. Once we get this set up, especially if we have a calculator, we can look for patterns. So with the 10 and the 4, if you do 10 divided by 4, you get 2.5. Now what we got to remember is we always have to go towards the variable. So if you look up in the numerator, this would be the direction towards the variable. So going from 4 to 10.5, we know that would be multiplying then by 2.5 or 2.5. So we'd have to multiply our numerator by 2.5 also to get an equivalent fraction. And so if we do that, basically is, 2.5 times 2.5, 2.5 times 2.5. Remember, if you didn't have a calculator, we would just change them to improper fractions, so like 5/2 times 5/2. So when you work that out, you get 6.25, or we could write that would be 6 1/4 pints of yellow paint that we need. Lesson 3, we're talking about proportional relationships and equivalent ratios. So the question here, they have a table, and the question is, are the perimeter and the side length proportional? So we kind of were getting in the habit on lesson 4 of doing our proportion as a y over x. And it's really not too bad of a way of doing it on this problem because the y values are bigger than the x values anyway. So, for example, 8 over 2, we do 8 divided by 2, which would be 4. 16 divided by 4, that would be 4 as well. And then 24 divided by 6 would be 4. So, are they proportional? Since our ratios are all equivalent, we would say yes. So we could say yes. All ratios are equivalent, or we could say they're all equivalent to 4 over 1, or they're all equivalent to 4, okay, something like that. So then number 2, write and solve a proportion to find the perimeter of a square when the side length is 12. So side length, we labeled that as our x. So we did y over x. And we always got 4 or 4 over 1. So we're trying to find the side length was our x, so that's where the 12 needs to go. And we're trying to find the perimeter. So a couple ways we could do this going towards the variable. We could go this direction. 1 times 4 is 4. 12 times 4 is 48. Or if you wanted to, you could go across. 1 times 12 is 12. 4 times 12 is 48. Whichever way you want to do that. Understand on that problem, and that's centimeters, by the way, 48 centimeters. Understand on that problem, really, you have a side length of 12 and it's a square, so you're just adding your 4 sides of 12 would be 48. So really, even independently of number 1, we could figure out number 2 pretty easily. Lesson 4, we're looking at constant of proportionality. That's that k value we talked about, y equals kx. Remember we talked about that k value we find by y divided by x. So Sally's going on vacation with her family. In 2 hours they travel 90.5 miles. If they travel at the same speed, write an equation to represent how far they will travel d in h hours. Okay, so they're switching things up on us here a little bit. They're having us use different variables instead of y and x. Probably what I would do first is think about what way seems more familiar to me, and that's probably how I want to do this problem. So in other words, we're going to find our k value, which is again is like our unit rate. So we could think about hours per mile or miles per hour. Which one sounds like something more familiar to you? Miles per hour. Okay, so we'll do miles per hour. So 90.5 miles divided by 2 hours. That's going to give us our miles per hour. And what we're saying by doing that, we're saying that the miles is going to be like our y, and the hours are going to be like our x if we do y divided by x. So when you divide that out, you should get 45.25, or 45 1/4 miles per hour. And again, that's like our k value, right? So if that's our k value, and then normally we've got y equals kx, our equation, normally we could just say our equation is y equals 45.25x. What's different is they're changing up our variables. They want a d for distance and an h for hours. So distance, that would be miles. So that's going to go in place of our y. We'll put a d instead of a y. And the x was the number of hours, and that's what we did there. So in place of the x, we'll put an h. So d equals 45.25h would be our equation. Again, same exact idea as what we're doing. It's just different letters that they're wanting us to use here. And if we look at number 2, table shows the weights of bunches of bananas and the price of each bunch. Identify the constant of proportionality, and then write an equation to relate weight W to price P. So again, they're using different variables with us. Like we talked about before, usually if money's involved, we're going to take the money divided by the other thing. So price per pound is what we're going to find here. And they basically told us that this was proportional, so these all should come out to be the same. Okay, so anyway, if you divide all these out, and you should get, this would be 45 cents per pound, and that'll come out the same exact for all three of those. So 45 cents a pound, and we want to come up with an equation. So again, normally we'd say y equals 45 cents times x. It's just they want us to use W and P. The question is which one goes where? Well, if you look here, we put the price in the numerator. Remember, it's y over x. So the y would be our price. So we're going to say P equals 45 cents times W. W was our weight, and that was our x value, as we put it. So that'd be an equation that we could use to find the price for any amount of bananas. 45 cents times however many pounds makes sense. Lesson I and 7, we talked about similar figures. One thing they could ask you to do is to find a missing measure. So for this one, they want us to find the length of the one rectangle. What we can do is do a proportion using the sides that match up. So the x matches up with the 5. Now I started with this rectangle in the numerator, so that's what I have to start with my second fraction also. So that means 3 would match up with the 2. Once you get your proportion set up, if you want to, you could just say x is being divided by 5. You can multiply by 5. Or if you want to look for pattern, you can. 5 divided by 2 is 2.5. If we go towards the variable, going from 2 to 5, that'd be multiplying by 2.5. And if you take 3 times 2.5, you get 7.5 or 7.5 centimeters. Another thing they could ask us to do in lesson I and 7 is tell whether two figures are similar to each other. One case we could talk about if we had two triangles. So, for example, if I have these two triangles, one has a right angle and a 30-degree angle, the other one has a right angle and a 60-degree angle, and we could look at these and determine if they're going to be similar or not. So in order to determine this, looking for our angles, the angles are not all the same. And so what we can do though is our knowledge of triangles, the three angles in a triangle add up to 180 degrees. So if we add the 90 and the 30 is 120 degrees used up. If we take 180 minus 120, that means our other missing angle up here is 60 degrees. At that point, if you wanted to in the other triangle, you could work it out and figure out that that other angle is 30-degree angle. I know these don't look like they're similar. My drawing wasn't the best here, but another thing at this point, actually, if you wanted to, you might notice we have a 60-degree and 90-degree angle. And remember we talked about there was a angle criterion. Or we could just say something about we have two angles in the triangles that are identical, so they are going to be similar to each other. And remember, we can only do that for triangles, though. Don't try and do it with rectangles or other types of quadrilaterals or things. Another thing, we could just be given some side lengths and ask if these are similar or not. What we can do is look for the corresponding sides. Corresponding sides should be proportional. So we could say the 2 matches up with the 3, the 7 matches up with the 9. These don't have decimals in them. We can't reduce either of them, so these are not going to be the same. So these are not going to be similar to each other. Okay, you could even with the calculator, yes, you could divide it out and get decimals, but I really don't need to do that with there not being any decimals in my fractions. No decimals in the fractions, the numbers should be able to reduce to exactly the same thing if these are actually similar to each other. So this should give you a little bit of an idea. Probably want to do some more reviewing maybe with Pearson website or other means in order to make sure that you for sure have this.